Find the point of intersection of these two lines given in a parametric form. So this is the set of equation for line 1, and we have another set of equation for line 2. So to find the point of intersection, we understand that the point that we find should be a common point to both lines L1 and L2. And this means that we can equate the equations of x to x as well as the equations of y to y and equations of z to z. So from this, we will determine the values of t and s and find the point of intersection. So let's do that now. I'm going to equate the x to x. So we have x equals 70 plus 1 from line 1. That means we will have the equation 70 plus 1 equals 4s plus 2 is the x for line 2. So this equals 4s plus 2. So let's say this is equation number 1. And now I'm going to equate the y to y. So we have y equals t minus 8. So that means we will have another set of equation, that is t minus 8 equals, here for line 2 we have y equal negative s. So I say that t minus 8 equal negative s. Let's say this is equation number 2. And finally we will have another set of equation for when we equate the z equations. So we will have 4t plus 1 equals 3s minus 2. Let's say this is equation number 3. So now that we got the equations in two variables, that is t and 8, we need only two equations to solve the variables t and s. So I'm going to utilize only these two equations to find the values of t and s. So let's say that if I use the equation number 2, that is t minus 8 equals negative s. So from this I can determine the value of s, that is if I divide both terms by negative 1, I get 8 minus t. This equals s. This is s. So now I found the relation for s in terms of t, which means I can now substitute this value of s into the equation 1, convert everything in terms of t and determine the value of t. So let me do that. So I'm going to do it here. This is 70 plus 1. We have 4 times of, in place of s, I'm going to replace it as 8 minus t. So therefore this becomes 4 times of 8 minus t plus 2. So this is an equation only in t, which means we can solve for t. So let's solve this. So this gives 70 plus 1 equals, we distribute the 4 and then we will get 4 times of 8 is 32 minus 4 times of t is negative 40 plus 2. So this becomes 32 plus 2 is 34 minus of 40, and on the left side we have 70 plus 1. So let me add 40 on both sides. Adding 40 will give 70 plus 40 is 11t, and this equals 34 minus 1, because this is actually 1, it is not 7. So let me correct this. So we get 11t equals 34 minus 1 is 33. Now we divide both sides by 11 so that we get the value of t. So therefore t equals 33 over 11 is 3. So we just found the value of t equals 3. And this means we can substitute into this equation where we will get the value of s. So let me do that. So therefore this becomes 8 minus of t, which is 3, equals s. So this implies s equal to 8 minus 3 is 5. So now we got the value of both s and t. We now verify the value of t and s by substituting into the third equation, and it should satisfy the third equation, that is it should become true. Otherwise we say that the lines do not intersect. So let's do that. I'm going to replace t equal to 3 and s equal to 5 into this equation, and when I do that I get 4 times of t is 3 plus 1 equals 3 times of s, that is 5 minus 2. So this gives 4 times of 3 is 12. 12 plus 1 equals 13. And here we get 3 times of 5 is 15. 15 minus 2 equal to 3. So this satisfies the third equation. We are getting a true condition, which means the value of t and s that we found is correct, and the lines do intersect at the common point. So now to find the point of intersection, we can either take the value of t equal to 3 or s equal to 5 and plug it into the original line equation. So either we can plug in the values of t into the line equation 1 to determine the point of intersection, or we can also plug in the value of s into the line 2 to determine the point of intersection. So let me plug in the value of t equal to 3 into the line equation 1. So I'm plugging in into the line equation 1, and this becomes, we have x which is equal to 7t plus 1. We know that the value of t equals 3. So this becomes 7 times of 3 plus 1, which equals 7 times 3 is 21, plus 1 is 22. So we get value of x equal to 22. Now let me plug in into y equation. So we have to plug in t equal to 3. So therefore this becomes 3 minus 8, which equals 3 minus 8 is a negative 5. And finally into the z equation. So we plug in t equal to 3. So therefore this becomes 4 times of t is 3 plus 1, and this gives 4 times 3 is 12, 12 plus 1 is 13. So we got the values of x, y, that is negative 5, and z, which is 13. So we say that the point of intersection of the two lines is x comma y comma z. This is the coordinate of the point of intersection. That is x is 22, y is negative 5, and z is positive 13. So this is the point of intersection of the two lines.